All right, we're going to go over a few of the things down here on our study guide for the Spring Final 2016. And the first thing we're going to go over is the different equations that you're going to need to know for the final. So if we start off, the first one you're going to need to know is density, right? And density equals mass divided by volume. When you do this one, you also probably want to include your density triangle. Density equals mass divided by volume. And then that way, if you're solving for mass, you would cover up mass. And so what it's telling us is mass equals density times volume. And if you were solving for volume, you'd cover it up, and that would tell us volume equals mass divided by density, along with this one. So that's an easy way to keep all of those different equations straight in your head. Then the volume of a cube, all right? So the volume of a cube is going to be length cubed. Another way of thinking about it is you're basically taking the length times the width times the height. And since all of those are the same, it's the same thing as cubing one side. Now, remember here, like let's say we had 2 centimeters times 2 centimeters times 2 centimeters. That would be a cube. We'd have 2 times 2 is 4, times 2 is 8. So we'd have 8, and then a centimeter times a centimeter times a centimeter is, whoops, don't know what that was, is a centimeter cubed. So the units, right, for a volume are cubed. The area of a circle, pi r squared is the area of a circle. The volume of a cylinder, pi r squared h. And the thing to remember here is, in the order of operations, make sure that you square the radius before you multiply by the height and pi. And since the radius is going to be in centimeters, that's going to end up being a centimeter times a centimeter, which is a centimeter squared. Your height is going to be in centimeters, and that's going to give you a centimeter squared times a centimeter, and that's going to give you your cubic measurement, your centimeter cubed, as far as the units go. All right, speed. The equation for speed equals distance divided by time. You can also create a triangle for this one, where we have speed down here, distance up here, and time down here. And then just like with the density triangle, you can solve for different things. So if you needed to solve for time, it'd be distance divided by speed. If you were solving for distance, it would be speed times time, which makes things pretty easy. Velocity equals displacement divided by time. Remember that velocity and speed are similar. Basically, velocity is speed in a given direction, because velocity is a vector quantity, where speed is a scalar quantity. So this just has a magnitude, this has a magnitude and a direction, and we represent it with a vector. So because it falls in here, we can have the same sort of thing. Velocity equals, this is going to be displacement divided by time. And then you can do the same thing. If you need to solve for time, you'd cover it up. You'd have displacement divided by velocity. If you needed to solve for displacement, it'd be velocity times time. Acceleration is, we have our v final, which is our final velocity, minus v initial, which is our initial velocity, divided by time. And when you solve for that one, remember, if something is speeding up, you're going to end up with a positive velocity. And if something is slowing down, you're going to end up with a negative velocity. All right. Force, Newton's second law, force equals mass times acceleration. So we can make a triangle for this one as well. In this case, we need mass times acceleration, so that would leave us with force on top. And I think you get the idea on how to use the triangle. Remember that when we measure force, we measure it in newtons. And what is a newton? A newton is the same thing as a mass times acceleration, the base units for those. The base units for mass is kilograms times acceleration, which is meters per second squared. So a kilogram times a meter per second squared is the same thing as a newton. Weight is a force, so it's also going to be mass times acceleration due to gravity. And because the acceleration due to gravity can change on different planets, and on our planet with how far away you are from the Earth, this could be variable. That's why when you go from Earth to the moon, you have a different weight because you have a different amount of acceleration acting upon you. Remember that on Earth, the acceleration due to gravity is 9.8 meters per second squared. For something like Mars, we found that it was 3.72 meters per second squared. So you're going to have less weight on Mars because you have less acceleration that you're multiplying your mass by. Momentum, we abbreviate with a P. P equals m times v, which means momentum equals mass times velocity. So we can make a triangle for this one as well. So we have our mass and our velocity have to be multiplied, which leaves us our momentum on top. Now, a lot of you mess up the units for momentum, but it's not hard. The SI unit for momentum, for mass, is a kilogram, and the SI unit for velocity is meters per second. So the unit for momentum is a kilogram times a meter per second, which is very similar to a Newton, but we don't have meters per second squared, so it is different. So don't make that mistake on the final. Now, the units for all of these different things, when it comes to mass, we go with the kilogram. When we start with volume, we're going to talk about the liter. When we talk about length, it's going to be a meter. Energy is a joule. Force is a newton. Density could be two that we've used in class, but typically we use grams per milliliter, or we call it grams per cubic centimeter. But we also had a lab where we measured it in kilograms per liter, but either of these would work. Weight is, so now we're on weight. Weight would be a force, and so weight is measured in newtons. Area is something like, typically it would be something squared, like a length squared, like a meter squared, or a centimeter squared. But the idea here is it's a squared unit for area. Speed is meters per second. Acceleration is meters per second, which we called meters per second squared. And then our momentum we just talked about, but that's a kilogram times a meter per second. So those are all the units you'll want to have. I don't know how much time I have left, but I'll start on this. And also on your note card for the final, you can also have the metric stair step, which I think it would be a wise choice to go ahead and put that on there. So we have our base unit here, and then we're going to move from the base unit either up or down. We can start here. We have a kilo. Then underneath the kilo is a hecto. Then we have a deca. The base unit, which is meter, liter, gram, whatever it happens to be. Then we have our deci, our centi, and then finally our milli. Now, remember, if you move to the left, you move the decimal to the left.